All right, so our first presenter is Yiyi He, who has been doing the project being supervised by Lisa T, Petra, I should have checked your name, but Czarniak, Yiping Li, Vetri, Thirthar, Valerie Maxville, it's quite a long list. Hilai, I should have practiced these beforehand, shouldn't I? And folks from both the School of Electrical Engineering, Computing and Mathematical Sciences, ECMS, Sir Charles Gairdner Hospital, and all of the projects are supported and, by the HIVE team as well. So this particular scholarship was supported by the HIVE and also the Faculty of Health Sciences here at Curtin. So over to you, Yiyi.
So hi, my name is Yiyi, and I'm here today to present my project, Gamifying Infection Therapy. This project is led by Associate Professor Lisa T, Dr. Petra Czarniak, and the team. So first of all, let's just watch a short preview of the video. Does it load? Does it?
The next slide. See if that's the problem.
Yes, it may be blocking the video because it's from the external source. If you just allow the access.
Yeah.
I'm sorry.
No. So Ash was in here testing this morning.
Yep.
And so I'm just going to launch that separately.
Yes. That's okay then. We'll just have to skip to the next one.
Can I dance or something?
It's all good, it's all good. Let's skip to the next. Okay, so now is a brief introduction of the background of this project. Game-based learning, GBL, also known as serious games, SG, is a method of harvesting learners' engagement from known game-related areas using various elements of gameplay. Defined more specifically as interactive software with its primary focus on education rather than entertainment. SGs have garnered significant attention due to their integration into healthcare education. Due to their potential to enhance learners' engagement and facilitate the learning process. This integration into the healthcare education is driven by the alignment with adult learning principles, including autonomy, control, and a sense of achievement. In summary, SGs offer a unique learning environment where knowledge acquisition occurs through gameplay, incorporating elements such as scoring system, content unlocking, and narrative integration. Building on this concept, our project integrates the essence of play and games into antimicrobial chemotherapy unit of the second-year pharmacy program. The game is based on the existing material filmed exclusively for this unit. Created by Dr. Petra Czarniak's team. This material includes a video that details the treatment of polymicrobial foot infection in a diabetic patient. This video is for in-class activities such as discussions and related queries to stimulate engagement and deeper thinking. Following the video, students complete a post-tutorial questionnaire mirroring the pre-tutorial one to assess the learning outcomes of this activity. And our game will try to execute these activities. And here are the roadmap. The project begins with the initial meeting where Lisa and Petra provided an overview of their content. In response, I presented my previous game portfolio to demonstrate the potential scope of this project. The concept pitching phase commenced within the same week. Due to my limited knowledge in pharmacology, it took several weeks of discussions and updates for the team to reach an agreement on the game's direction. Concurrently, I was developing some basic game mechanics, including movement like walking forwards and backwards, looking up and down, and object interaction, such as picking up and dropping. Field research involves Hilai guiding me through the hospital to observe daily operations and activities. This experience was crucial for gaining insights into the practical aspect of the project. Lisa facilitated the visit to Curtin nursing simulation suite, where I captured photographs for the photogrammetry and conducted a LiDAR scan using my phone. Feedback and development. At this stage, I'm seeking feedback from both the team and the audience on potential improvements or additions to this project, although there's already a substantial amount of enhancements to work through. The project will continue with further game development and refinement based on this feedback. Looking ahead, the next phase involves completing the game and distributing it to students for their participation and feedback. The supervising team will then conduct analysis based on the game's performance, assessing both its successes and areas for improvement. And we're currently here. Terms and tools. Before I start explaining my development process, I first need to explain a few terms I'll be referring to in my presentation. So assets are any game object, including code, models, audio, and image that can be used inside the creation of a game. Model would not be referring to the models that work on stage. It is a three-dimensional object that can be rendered inside the computer. Textures can be used as materials to render the otherwise colorless models. And UV, in the context of 3D modeling, refers to the 2D texture coordinates that are mapped onto the 3D, as shown in the picture here. The picture shown here is a game from League of Legends. This is a typical UV for character unwrap. You can see clearly on the 2D UV on the side where the mouth of the character is, and it is here, and you can see where the eyes are as well. And here are also a list of development tools that I've used throughout this project. So first up, we got Unity for assembling all the game assets, Maya for modeling, Substance Painter and Sampler for texture creation, and Photoshop for UI, quiz game, and 2D assets, Scaniverse for capturing the LiDAR data, C# is for the main programming language for Unity. It makes every action run as intended. GitHub for version control, allowing rollbacks if anything inside the project goes wrong. Monday.com goes for task management, and lastly, Microsoft Teams for weekly meetings and file sharing and management. And here's some programming. The character controller is based on a tutorial named First Person Movement in Unity from Brackeys. Walking backwards and forwards, looking left and right, the movement controller is designed to always align the player's movement direction relative to the direction they're facing. This ensures a more intuitive and responsive gaming experience where the player's orientation directly influences their movements within their game environment. The pickup mechanism is implemented through a raycasting approach. If this raycast intersects with an object tagged as pickup, the player is prompted to interact with the object by pressing E. Dropping the item is also contingent on a true and false variable. If the variable is true, indicating the player is holding onto something, then the item can be released from the holding position. Additionally, there's also the R key that can independently rotate from the player's camera movement. And on the side, there's also opening and closing door using the E button. This should move, but it doesn't move. It's okay. And here are some more programming. So more implementations of the code, such as the sitting code based on YouTube tutorial. Oh, that's not it. Oh, how do I go forward? Oh, okay, here. More implementations of the code, such as the sitting code based on the YouTube tutorial How to Sit in Chair in Unity by Ahmadzai. The primary function of this code is to switch between the two states of the player character, standing and sitting. As you can see on the camera view, on the engine view, that there are two little yoga mats. So the big one's the current player, and then if we interact with this chair object, it switches to the tiny yoga mat, which fixes and looks at the screen only. And here are the switch view buttons, switching between the material and looking at medication charts, and a chart toggle to flip through the materials. And in collaboration with Petra, the questionnaire was developed using her question base. The scoring system is designed to reward the correct answers with higher scores, especially the player answers quickly. To maintain a balanced and encouraging gameplay experience, the wrong answers do not incur penalties nor reduce the existing score. Additionally, a final score page is included to allow players to compare their current performance with previous performances. And menu implementation enables students to enter their student number for a more automated and efficient approach for the teachers. The results will then be linked with their student number and be outputted as a file that can be opened in Excel. During our project, Lisa coordinated a session at Curtin Simulation Nursing Suite for LiDAR data. The LiDAR data was processed into a detailed model, which after exporting and texturing, integrated into our game as a key asset. This experience prevented me to having to create all these models and textures by hand. And 3D modeling occurs when a suitable model are not available online or when existing models do not align with our specific requirements. The modeling process in Maya typically begins with basic geometric shapes, such as planes and cubes. By just adjusting these vertices and faces, the models are then sculpted into their desired forms, like these. This is me trying to cut the previous model that I was taken from the simulation suite. Adjacent to this, the image on the right displays a UV unwrap process. UV unwrapping is a crucial step in preparing our 3D model for texturing. It involves unfolding the model, similar to opening a box, to create a flat surface that can be easily painted and textured, like this. Material creation. During the development process, materials were categorized into two distinct groups. The first one being the widely used materials, which are integrated into substance sampler. These are generic materials that does not require specific tailored models but are versatile for various applications within the game. Examples include wood textures for tables, ground textures, and wall textures on this side. And the second group consists of specific textures, which are the majority of the game assets. This category includes a unique model such as chairs, monitors, and many others, each requiring individual attention to texturing. For these, Substance Painter was employed, as it allows the application for multiple different materials on a single model. An example of this is the door model, which features a combination of textures such as metal, glass, and wood, each contributing to its realistic appearance. And assembly. In the game development, integrating assets involves more than just using pre-made texture maps. These maps must be compiled into materials, which are then applied to the respective projects in the game. Here's an example of this process. To create the paper texture, we import the relevant maps, generate a material, then create a material for them, and then drag and drop like this onto the paper materials, and same is done with the folder, like this. And this is like a typical example for the material where you drag and drop all the maps from this side, the folder side, into the surface inputs. And lighting and URP. URP stands for Universal Rendering Pipeline. It's a common pipeline to use when you would like a more realistic portrayal of the environment. In the game scene that I've developed, as illustrated on the screen, the initial version appears without rendering. However, by incorporating multiple light sources and reflection probes, the scene undergoes significant transformation, achieving a much more realistic appearance. And in conclusion, reflecting on the past 10 weeks, I'm pleased to report that we have met most of the objectives that we set out to achieve within this time frame. The accomplishment leads us to this question: what comes next to our project? We're excited to announce Dr. Brian Lowe as the new lead supervisor for the team. His expertise and leadership are anticipated to bring fresh perspectives in our endeavors. In pursuit of our project's scope and impact, we have applied for further grants. These funds will support the continued support of the game, continued development of the game, with the aim of extending its reach not only to the pharmacy students, but also for those studying medicine, nursing, and dentistry. The next phase of our project will focus on enhancing the game's educational value. We plan to implement a scoring system based on the movements and actions developed during this project. This feature is designed to increase students' sense of achievement and motivation. By introducing challenges that will require application of pharmacology knowledge to overcome, we aim to foster a more engaging and effective learning environment. Our goal is for the students to achieve a superior learning outcome compared to the traditional teaching methods. And lastly, I would like to extend my heartfelt thanks to the following people for their invaluable support and guidance during this project. And thank you so much for listening. Please raise your hand for any questions.